We will give just a second for the Zoom connection to set up its live stream. We are going to be streaming this event live to the Reserves Facebook page. So if you don't want to be on screen, feel free to turn off your video down in the bottom left corner of your Zoom panel there. And I see everybody's muted. That's perfect. Please remain muted throughout the presentation. We will have a chance at the end for question and answer period, but we will ask you to put your questions into the chat. So if you all will hang out for just a moment, we will get started in just a second. All righty. Well, we are officially live, and welcome everyone to our second ever virtual evenings at the Estuary. Gotcha. So again, just some logistics for in the room tonight. Please don't turn on your video. Please leave your video off. Please leave yourself muted if you're joining us from Zoom. That just decreases the chances of any odd background noises that could interrupt. Just like that, which is why I'll mute at the end of my spiel here. If you're joining us on Facebook, feel free to add questions into the comment section. We will be trying to monitor both the Facebook feed and the chat here tonight. I do have Taylor Honrath, who is the development director over at the Elkhorn Slough Foundation, who will be moderating our Q&A period later this evening. So if you have questions and you're on the Zoom platform, feel free to send them to him or to put them just directly into the chat feature. And with that, let's go ahead and get started. My name is Ariel Hunter. I'm the Community Outreach Coordinator for the Elkhorn Slough Reserve. We are thrilled this year to theme our evenings at the Estuary talks around community conservation and action. Folks taking action to help promote their community, and especially the well-being of their environmental community. We have two speakers tonight. We'll have a short 40-minute period where we'll be presenting, followed by probably 20 to 30 minutes of Q&A after that. Our speakers are Kass Green, who will be sharing first, of Kass Green Associates. She has 30 years plus of time spent managing GIS and remote sensing projects and professionals. She's done research with GIS, and she's primarily worked with vegetation mapping, which is what we'll be talking about primarily tonight. And she also, I found this out, is currently part of a leadership team that is mapping wildland fuels within 5 counties of the San Francisco Bay Area. So that's, again, fire is becoming a really important thing. And that sounds like an awesome project. She helped build the map that we will be sharing tonight that's on the Elkhorn Slough Foundation's website. And our other speaker is Dunkell. He is the Elkhorn Slough Foundation Stewardship Director of at least 3 years now, I believe, Dash. And he came to us from the Ventura County, or the Ventura Land Trust. But he was originally a Santa Cruz local, grew up exploring the trails here at the Elkhorn Slough, and has spent a great deal of his time working on understanding the bigger picture of this watershed and how the 4,000 acres that the foundation conserves factors into the overall well-being of this watershed. And he'll be talking a lot about how to sort of take that scale down from the watershed, huge scale, to your backyard as far as managing invasive species. So with that, again, feel free at any point in time to drop questions into either the Facebook comments or into the chat box. And I'd like to bring on our first speaker, Kass Green.
Great. Ariel, can you see my presentation okay?
Yeah, looks good.
Great. Okay. So thank you very much for having me tonight. This is really exciting. The project I'm going to talk about is life form and tidal wetlands mapping in the Elkhorn Slough watershed. As Ariel pointed out, I've had a pretty long career, but this project has been one of the capstones. I had so much fun and I learned so much on this project, so I'm always really happy to talk about it. And there we go. So I'm going to give you, I'm going to talk about the project goals and the funding, and then I'm going to talk about the methods, and then about the results. Mostly I'm going to talk about the methods and how we actually made the map. So the goals of the project, there were two different goals. One was to map the uplands of the Elkhorn Slough watershed to the enhanced life form level. And what you're seeing right now is not a photograph taken from an airplane, but actually an image, airborne image that was taken from an airplane, multiple images draped over a digital elevation model. So it's a 3D look at the landscape, and this is some of the uplands of the Elkhorn Slough watershed. And then the second goal of the project was to map the tidal wetlands of Elkhorn Slough to the alliance level. So what does that mean? Enhanced life form is, it's big groups of vegetation types, hardwood trees, or riparian trees, upland hardwoods, deciduous hardwoods, conifers, two different types of conifers. I'll go about in this more, land use classes, wetlands classes. It's a very generalized map. But when you get out down to the Elkhorn Slough itself, we're mapping to the alliance level, which is much more detailed. I'll go through the classes in a little bit. So the map of the slough is much more detailed than the map of the uplands, but together they create a tool that can be used to manage the entire watershed. So the funding, I'm going to talk about the project and the funding for the project, but you can see I've got a graphic here that's a lot bigger than Elkhorn Slough. Elkhorn Slough is just this area right here, but the project is much bigger. And that's because this project is part of a multi-county project that NOAA is supporting to map the tidal wetlands of San Mateo, Marin, Santa Clara, and Santa Cruz counties. So this project is also part of the NOAA project. NOAA funded the mapping of the tidal wetlands to the alliance level. Then the Elkhorn Slough Foundation came through with the funding to map the entire watershed to the life form level. So it's a combined project, a consortium, which most of our projects are, that created the wherewithal to be able to create this really detailed map. This, as I said before, is just a small part of a much bigger project. We started in Sonoma County in 2017, where we mapped fine scale vegetation in Sonoma County. That moved to Marin County and then into San Mateo County. Recently, we were able to raise all the funds to extend this same project into Santa Cruz and Santa Clara counties. And as I said, NOAA came in, that was just going to be for uplands, but then NOAA came in with funding to support the tidal wetlands mapping also. Napa County on their own had us map the wildland fuels of Napa County. And now we're trying to get funding to map the fuels and the life form and the tidal wetlands of Contra Costa and Alameda County. So one of the goals of my career, the end of my career now, is to be able to get the whole Bay Area mapped to this fine scale with the wetlands map and also with the fuels maps and all the tools that are used for wildfire risk assessment. So it's been a great project. It's been going since 2013 is when we started Sonoma. We finished it in 2018, and now we're just clicking off all these different counties. So it's really been a great thing to work on. So my work has been international. I've mapped in Ethiopia and several places of the world. It's so nice to be able to map in my own backyard finally. So the extent of the Elkhorn Slough project is, again, the Elkhorn Slough watershed. So it's the entire watershed of everything that drains into Elkhorn Slough. So now I'm going to talk about our methods, and they're very straightforward. Whether you're making a map just through manual interpretation or through some automated or semi-automated techniques, there are three basic things you have to do. You have to understand the variation in the ground. You have to understand the variation in the imagery and the ancillary data. And then you've got to link the variation in the ground to the variation in the imagery and the ancillary data. So you can see from this example, it's really clear. When you're on the ground on the right-hand side of the image, you can see the Spartina, and then the next ring in is the alkali bulrush, and the next ring in is the pickleweed. So you can see that the imagery on the left-hand side, this is an infrared image, which allows us to see things that humans can't see, to see colors that humans can't see on their own. And you can see that there's a real link in between the variation on the ground that we can see in that photograph, this photograph on the right, and what's the variation that's actually in the image. So we're trying to exploit that variation and capture as much of it as we can. So the first thing we have to do is we have to understand the variation on the ground. That means we need to go to the ground. So the first thing we do is go to the ground. We develop a vegetation classification scheme, and you can see right now the life form classes for the upland area of Elkhorn Slough. So it's a very generalized, again, bare soil, water, chaparral, soft scrub, on down to redwoods and or Douglas fir or pine and or cypress, riparian classes, many different farmland classes, but a very basic map at the life form level. Then we take this class, the Tidal Marsh, and we break it into a more detailed classes. This is the alliance level mapping for the Tidal Marsh. And you can see we're mapping alkali bulrush, saltgrass, pickleweed, the Spartina, and there's actually no Spartina in Elkhorn Slough, but we're mapping all the different classes of the tidal wetlands. This classification scheme was developed by the California Native Plant Society and the California Department of Fish and Wildlife. And it's in the Manual of California Vegetation, which I have around here somewhere, but is a really, really thick book. And so we tend to use those classes so we can ensure consistency from county to county. And so that all the work we do, it can be used on a local level, but also combined and used on a regional level. So we're always using the classification scheme from the California Native Plant Society. They're a partner of us with us in every project. And then of course we go to the ground. These are two of my favorite people that I like to go to, especially wetlands with, Mike Vasey and Mark Tuckman, who is the head of Tuckman Geospatial, the organization that I work with to do this work. Mark used to actually work with me when I had a large firm, and we've worked together really closely for about 25 years now. And I just have gotten to know Mike, and I really enjoy working with him. He's taught me everything I know about wetlands today. So one thing we do, we go out to the ground and we take calibration points and calibration polygons. You can see in this, there are several points and there are several polygons. And we're out in the field with, if you notice from this picture of Mark, he's got an iPad in his hands and he's using the ArcGIS iPad collector app to collect data. And that's what we do. We go to the field with our iPads and we collect data, and we're trying to capture, again, the variation on the ground. I'm going to zoom into an area that's near the mouth of the slough, and you can see more detail on the different, these are called training polygons or calibration polygons, training sites, where we take samples of the variation in the vegetation that we're trying to map on the ground. And this gives you an idea of the data that's collected. You'll see that, yes, this site, actually this site it's this one right here, this pickleweed site. And it says the notes across the road is also pickleweed over here. And this site is 90% pickleweed. And then of course we also, sometimes we go into even more detail, but this is a good example. And then of course we always take a photograph. So the photograph is linked to that site. All of this is done in a geographic information system. So it's all organized geographically. All the data, all of the photos, all of our field work is all organized in the geographic information system. Then the next step, once we understand the variation on the ground and we have a really detailed classification scheme with rules that tell us, when we're at the ground, what we're actually seeing based on those rules. The next step is that we need to understand variation in the imagery and the ancillary data. So we have imagery to use for this map. We start with Landsat and Sentinel data. Those are satellite systems. They're very coarse resolution, 20 to 30 meter spatial resolution. So that's 25 to 30 meters on a side. So it's very coarse, especially for doing fine scale mapping. But the great thing about it is that it's taken every 3 to 4 days. So you get temporal resolution. You can see how things change over time. Great example is you use it to determine the difference between evergreen hardwoods and deciduous hardwoods. Just because the deciduous hardwoods, they lose their leaves. When you think of wetlands, saltgrass and pickleweed change in the fall, their colors change, and we can use this multi-temporal imagery to distinguish different types from one another. Our main source of imagery, though, is high resolution imagery flown from an aircraft. And we had that for Elkhorn Slough. We used a system called the National Agriculture Imaging Program data. It's in the public domain, so any of you can get this data. It is flown at a 0.5 meter resolution, but for a little bit of an upgrade, you can contract with a company named Hexagon, who coordinates all the nape collections nationwide. And they fly a little bit lower so they can get a higher resolution. So for about, I think, $2,400, we were able to get the nape imagery for Elkhorn Slough at 3 and 6 inch resolution, which was fantastic and frankly what is needed to get into those wetlands and to do a fine scale map. So you can use the nape data, it's free, it's in the public domain. If you need higher resolution, you just pay a little bit of an upcharge and you get that. The great thing about nape data is that it is 4 bands. So this is true color, red, green, and blue, that's what humans see, but it also has a 4th band, which is the near infrared. And that allows us to really break out vegetation types. So we have all 4 bands that we can use. Other data that we use is we have LiDAR for Elkhorn Slough. And I want to really do a shout out. I saw that Carol is on the phone, Carol Ostergren with USGS, and I want to do a shout out to USGS for all the work they have done in providing LiDAR to the public in their 3-depth program. Every single county that I showed that we're working with, we have worked with USGS to get that LiDAR data for the county. And there was really good LiDAR data for the entire Elkhorn Slough from USGS's collection. And there was also even higher resolution LiDAR over the slough itself that the Elkhorn Slough Foundation had. So really great data. And that LiDAR data allows us to map elevation, slope, aspect. Also, we can do vegetation height. There's all kinds of different data layers that we can pull out of the LiDAR data. And then we have other ancillary data sets. We will use anything we can get our hands on. So for Elkhorn Slough, they provided us with multiple data sets of research that had already been done in the slough, plot locations that we were able to use in creation of the map. The final thing we have to do is we have to link the imagery, the variation in the ground that we've seen in the ground to variation in the imagery and ancillary data. If they don't link, you can't make a map. So you've got to find out where the imagery and the ancillary data are highly correlated to the variation in the ground. And where they aren't highly correlated, you got to make the map some other way, which is typically manual editing. So the first thing we do is we segment the image. So this means we run an algorithm. It's an eCognition algorithm. The software is called eCognition, and it segments the imagery based on spectral response and what you're seeing on the imagery. So you segment the imagery, and here you can see the imagery segmented into different polygons of like spectral response. So that's the first thing you do when you're going to make a map like this. The second thing, then you've got to label those segments. You see where you've divided up the landscape into polygons, but the next thing we have to do is actually label those polygons as to what kind of vegetation or land use land cover type they are. So the way we do that is we do something called machine learning. And you've probably, machine learning's in the press all the time now. It's what Facebook and Google and everybody uses to understand, your buying patterns when you're buying. But we use it to actually link the variation on the ground to the variation in the imagery. We take those training sites that I talked about here. We've collected them all over Elkhorn Slough here. We take these training sites and we drop them through all the data sets we have. So we've got imagery, we've got slope, aspect, elevation, we've got closeness to shore, we've got tidal stages, we have canopy heights, all kinds of different, we have the Sentinel imagery and the Landsat imagery giving us that multi-temporal aspect. So we drop all these training sites that we've taken over here, we drop those through the landscape. This is a Sonoma County example, and we drop them through the landscape. And then we use machine learning to build algorithms that say, pickleweed is usually this spectral response in the fall, and it's this spectral response in the spring. It has got this canopy height. It is obviously usually only found on flat areas. And so all these different variables, machine learning algorithms, they build the algorithms that help us label all of the segments. And once the algorithms are built, the segments get labeled. But that's not the end. It would be great if it was, but it's not, because it's not that easy. So the next thing we do is we review the map and we edit it. And we edit it manually. And this allows us to capture the things that we can't do with the machine learning. But by using machine learning, we're allowed to focus the computer on the things it can do easily. And then you take that highly trained, very valuable photo interpreter, the image analyst, and you only focus them on things that the computer can't do. And so we spend a lot of time doing that manual editing. When we're done with the manual editing, we then send the map out for local expert review. So this shows you, we had several reviewers, both NOAA reviewed the maps, but more importantly, local Elkhorn Slough experts from the foundation, from all kinds of different organizations reviewed the map. This just shows you this map shows you some of the comments. They're color coded by person. And it shows you the different level of comment. If I zoomed in, you'd see even more spots. So lots of really good comments from those local experts. So we take the map that we sent to them, which again had been edited, and then we edit again based on those comments from local expert review. So the third thing that happens is we end up with a map. And so here's the map for the Elkhorn Slough watershed. You can see I'm going to zoom in a minute so you can see more of the detail of the map, but this creates a management tool that folks can use to manage the entire watershed. And we all know that activities in the watershed are going to affect the slough. So you have to have not just the wetlands mapped, but the entire watershed, so you can effectively make management decisions. And we'll zoom into this map just a little bit. Here's the mouth of the slough again. And you can see the detail of the map, that it has the channels of the slough, the different types of vegetation type. It's a very complex area. I love the old Salinas River area with lots of complexity in the wetland. The uplands have got the same level of detail. So it's a really, really powerful map that goes at a very small scale. That's why we call it fine scale. It's actually a large scale, but we call it a fine scale map because you can see a level of detail that's, typically hasn't been available in different management programs. And here's a great map. Charlie Endress took the Elkhorn Slough map and turned it into a cartographically beautiful map. This is available also on the Elkhorn Slough Foundation site, and just gives you an idea of the topography of the area and the beauty of the area. So I'm going to do a summary. What made this project possible? There were several things. One is the cost of ortho imagery and LiDAR data collection and processing have come way down over the last 10 years, way down. So it's just a fraction of what it used to be. So that allows us to have LiDAR, We've always had imagery, but now we've got LiDAR and we're using LiDAR a lot. Second thing is that the reliance on the California Native Plant Society, the NVCS, the Manual of California Vegetation, and the California Department of Fish and Wildlife's classification of vegetation. That allows us to, again, have local management, but also region-wide management, because the map will go across multiple counties. Then most important probably is the implementation of innovative technologies that I've already showed you, such as the image segmentation, the machine learning, the GPS-enabled digital field collector. I was going to show you guys my iPad. Here it is. Here's my iPad that goes to the field with me. That has made a huge difference. And then finally, the economies of scale from region-wide cross-organizational collaboration. Because these projects are so large and they're being done across all these different county boundaries, it really produces economies of scale that make the project affordable when it used to not be affordable. So that's for my talk. Here's my contact. I don't know if we're sharing the slides or not. I'm more than happy to, if you guys want to. And now I think I will switch it over to Dash. Stop sharing. There we go.
All right. Wow, Kass, that was great. I've seen a version of that presentation before, but that was still so interesting. And yeah, it's really amazing all the things that have to come together to make these projects happen. But yeah, hats off. Thank you again for all the hard work on this. So yeah, round of applause. Very nice. I guess it's now my turn to take that map, this beautiful map that Kass built with this whole team, and kind of explain how we use it and sort of what it means for the foundation and yeah, our partners and everyone who works in the Elkhorn Slough. So I'll one second, get going here.
And just a quick note, we will drop the link to the map, if you haven't seen it yet, into the chat. And it's already linked if you're on the Facebook page. So check out the chat in just a minute for that.
Great, thank you, Ariel. So as Ariel mentioned, my name is Dash Dunkell. I'm the Stewardship Director for the Elkhorn Slough Foundation. And here's the beautiful Elkhorn Slough. But I just step back a little bit and make sure that everyone understands who we are. So Elkhorn Slough Foundation, we're an accredited land trust, nonprofit organization. And our goal basically is to conserve and restore the Elkhorn Slough and its watershed. And we do that in a few different ways. We do that through land acquisition. As I said, Land Trust is a nonprofit organization that owns and manages or oversees land. So we acquire land in the Elkhorn Slough watershed. Then once we have that land, we steward it. So we manage the land in a way that conserves the slough, protects the slough. And in our case, this is close to 4,000 acres, includes even agricultural properties. We have a historic cattle ranch and lots of beautiful upland and a little bit actually of the wetlands of the slough itself. We do that through education and outreach, events such as this, field trips, working with local schools and community groups. And then perhaps most importantly, we do it with partnerships. It can be a little bit confusing. Ariel is actually an employee of the California Department of Fish and Wildlife. I'm an employee of the Elkhorn Slough Foundation. And then we also have a lot of people working at the reserve who are funded by the federal government through the National Oceanographic and Atmospheric Administration. The three parts come together at the Elkhorn Slough National Estuary and Research Reserve, or ESNR. Unfortunately, there's going to be some acronyms. There just has to be when you have so many groups and things going on. So ESNR is the reserve and is this collaboration sort of between the three groups. And then Kass explained this a little bit. I thought I'd just go back and make sure everyone kind of understands what a watershed is. Could also call it like a drainage basin, might be maybe an engineering term for it. In Spanish, a cuenca. Hawaiians would call it ahu pua'a, but it's, it's all the lands that drain to a certain point. So if you take a certain point in the landscape, then everywhere that a raindrop falls and would drain to there, sort of the watershed of that area or that spot. We like to talk about ridgeline to tideline, the foundation. We're thinking about protecting the Elkhorn Slough, not only down in the wetlands, but all the way up to the tops of the ridges. And in this case, you can define the watershed in a few different ways. Like many things in science, it's not totally black and white. For instance, the Salinas River at times will actually flow into the Elkhorn Slough. The Salinas River watershed is obviously much bigger than 46,000 acres. But it also will sometimes usually flow into the ocean straight out, you see at the bottom of this map. Likewise, there have been times in the past when the Pajaro River has flowed into the Elkhorn Slough from the north as well. But in this case, this is the kind of commonly accepted definition or map of the watershed here. And as we could see from the beautiful map that Kass showed, and even from this aerial image, lots of different land uses, lots of different habitats in this fairly small watershed. And so this project was actually funded through a grant from, the mapping portion was funded through a grant from the Integrated Watershed Restoration Program. And this is another collaborative group. In our case, we got this through the Resource Conservation District of Monterey County. And the purpose of the Integrated Watershed Restoration Program is to facilitate projects that improve fish and wildlife habitat and water quality in these three counties here on the Central Coast. And in our case, the big driver was actually to understand eucalyptus in the Elkhorn Slough watershed. We wanted to know more about the distribution of eucalyptus, sort of understand better its impact on the watershed, and think about it in regards to watershed restoration, and to plan for eucalyptus removal from the Elkhorn Slough Foundation properties where appropriate. And finally, there's a little bit of funding in there for public outreach to help people understand sort of the impact of non-native species, particularly eucalyptus, on the watershed. And as you can imagine, most of the land in the Elkhorn Slough watershed is actually in private hands, right? So outreach to the public is going to be really important if we want to have watershed-wide effects and impacts. So here's another beautiful map created by Charlie Endres, who Kass mentioned. He's our resident GIS expert. This shows the Elkhorn Slough Foundation's properties that we own, as well as, and in the center there, outlined in red, the reserve. And you can see we have, right now it's about 3,572 acres. It's fluctuated up and down as we have acquired properties and sometimes transferred them to other public agencies. But right there, that's about 8% of the entire watershed. So that's a pretty good amount if you're trying to have impacts and trying to protect the slough. And you can see our properties are kind of clustered around the slough, close to the slough, and even including You see sort of like this property named Cowell here, including even the tidal wetlands themselves. And so if you count properties that we've acquired and then transferred not only to the reserve, but also to state parks, there's another 800 acres that we've protected, which brings it to about 10% of the whole watershed, which is pretty impressive, I would say. And I saw my colleague, Kevin Contreras, he's the acquisition manager for the Elkhorn Slough Foundation, I think is watching today. So a round of applause for Kevin for all this hard work acquiring all these amazing properties. And so one of the ways that this map is really important is for acquisitions. We've been focused on properties that directly impact the slough, right, as part of our mission. That can be either positively or negatively. And I've heard it said the best of the best and the worst of the worst. So here's an example of one of the worst of the worst. Those of you who've followed the foundation have heard, I'm sure, about Sandhill Farm. This is a photo of Sandhill Farm prior to our acquisition of it. It's definitely one of the worst of the worst. So it's this farm here. You can see all this bare soil. This was after a big rain. This is all sediment fan down here. So sediment that eroded off the hillside. And then all this sediment plume here in the water of the North Marsh of the Elkhorn Slough Reserve. This is all a result of runoff from this poorly managed farm. So this is an example of one of the worst of the worst. They're pretty easy to identify in certain ways. We can see the impacts directly. But then when it comes to the best of the best, that's a little bit trickier. Here's obviously a really beautiful property. It's a landscape at the Porter Ranch. And yeah, really beautiful example of amazing springtime displays of wildflowers we get. So what we're looking for, can really depend on what our goals are. So intact habitat is really important. That is maybe something that would make the property the best of the best. Rare species, neighboring land use, that can really impact the conservation value of a property. Let's say you have a beautiful intact habitat, if it's surrounded by terrible land uses, that might not be the best property to protect or to acquire. And for that reason, we really need to understand the watershed scale. My copy of this map, I guess, didn't render so great, but this is Charlie's map again. And it just helps us understand, understand properties, understand the watershed. If we're trying to acquire or protect certain types of habitat, then we need to understand how it's distributed, where it is. We need to understand threats. If one property is being developed next door, then maybe that means the threat is then coming to that next property. So understanding these spatial patterns is really important for this portion of our work. And then I might be sort of violating PowerPoint rules here. This is kind of a busy slide, but basically on the left here, this is the distribution of these life form groups for the watershed itself. And then on the right is Elkhorn Slough Foundation lands. And you can kind of see the distribution of these life form classes. Here in the watershed, almost 4,000 acres were developed out of 45,000. So close to 10%. You've got grassland, hardwood forest. And then a couple of things I want to point out. You have chaparral, maritime chaparral, one of the most sensitive ecosystems that we have in the Elkhorn Slough watershed, about 1,000 acres in the entire watershed. And on ESF properties, we actually have 371 acres. So we have more than a third. We've already protected more than a third of this sensitive ecosystem type, the whole watershed. which is really amazing. Likewise for riparian forest, we've protected 165 acres out of 700. So that's another good portion, I don't know, a fifth or something. And then here we have eucalyptus. And this was really surprising to me once I saw these maps, was that there's actually, yeah, almost 2,200 acres of eucalyptus in the watershed, quite a big amount. And the Elkhorn Slough Foundation actually only has 105 acres. I thought it was a little bit more, but yeah, 105 acres of eucalyptus is still a lot to manage, a lot to deal with. So this kind of just gives you an idea of another way to use this map. We don't have to use it in its map form. We can also like pull the data out and use it in this sense, get statistics, help us understand the watershed in a different way. And so now on to stewardship. I'm the stewardship director, as I mentioned. I probably shouldn't even be talking about acquisitions, but I do think the map is really important to that portion of our work, and I help a little bit with acquisitions, but not that much. So on the stewardship team, those of you who've maybe come out to any volunteer events in the last few years, or maybe follow us on social media or volunteer, know Ken and Connor. They both are full-time on the stewardship team, doing a lot of the hard work in the field. We also have Mary Paul, who works, she's a hybrid. She works for the reserve and for the foundation. Totally caught up in that three-part diagram. And then in the center there, driving the boat, Charlie. He's not just good on a computer, he's got other skills too. So this is the stewardship team for the foundation. Of course, lots of other people help with stewardship work. Plenty of other foundation employees get out in the field and help pull weeds and do different things when we need help. And plenty of volunteers too. So we have a great cadre of volunteers who come out and help us with the land management. You can imagine owning over 3,500 acres. There's a lot of work to do. So there's plenty of really fun things. You get to go to these beautiful properties. Ken's checking out, looking for amphibians, one of our ponds. On the right, I was checking out the cattle at the Porter Ranch and checking on the state of the grasslands there. Lots of really fun, interesting things to do with land management. Other things maybe not quite as fun, but really important. With being a rural property with all these different land uses in the Elkhorn Slough watershed, it means that we do see issues with trash dumping, with contamination. And so this is another part of our job here. And, this is also something that when we're looking at the map and thinking about the watershed, our experience from owning these properties and understanding sort of the history is really important to helping understand what managing these properties is going to take. Oftentimes, if it's been farmland for a long time, there's potential that there could be agricultural waste. If it's near a road or near a property that has a lot of junk on it, then we might realize that there could be impacts from that neighboring property. Another thing that we do is habitat restoration. And here we have a beautiful socially distanced planting day not too long ago this winter. And on the left, some planting of willow stakes. And this, once again, the understanding the landscape, understanding the watershed is part of how you plan a habitat restoration, how you decide how you're going to restore the land, what you're going to plant, and understanding these variations is really important for the work we do. We're going to do a lot of other really fun stuff. Here we are making an amphibian pond. And so understanding the watershed in a small sense, like if you're building a pond, you want to think about what's draining into that pond. Where's the water going to come from? How much runoff is it going to catch? Is there potential for chemicals or damaging runoff from another property? You don't want to build a pond for endangered amphibians only to have it contaminated by something upstream. We're going to do all kinds of fun experiments. Here's a little floating wetland that Ken made to put in a pond to help the water quality. These plants suck up nitrogen and nutrients from the pond and take it up into the plants themselves, and that helps clean the water. Little experiment, it worked really well. We're going to do all kinds of fun things like drive where we shouldn't. We get to check out all the amazing creatures that call the Elkhorn Slough home. We help, restore the landscape for animals as well. Here's a bunch of bluebird nests, I believe, that Ken built that were then deployed on Elkhorn Slough Foundation lands. We try and understand the animals that live on our properties. And I talked about a little bit earlier about understanding neighboring land uses and connectedness. And this is one reason is we need space for animals to be able to move between properties. Wildlife corridors are really important. And so understanding that aspect of the landscape is really key to protecting these animals. And then anyone who's joined on a volunteer event has probably done some of this. One of the big parts of stewardship, just like probably in your own backyards, wherever you live, is weeds. It's invasive species, invasive plants. On the left there, Ken's holding a Jubata grass, which is one of the nastiest invaders on our properties. Here's Kevin with a French broom earlier this year. And then Connor standing in one of our eucalyptus groves. Definitely a different scale there. You can't quite pull those eucalyptus out like these other little plants. And so this work was sort of focused on eucalyptus, And I just want to make sure everyone understands, there's lots of different species of eucalyptus, but the one here in California, and one that's most common, the one we're concerned with here in Elkhorn Slough is Eucalyptus globulus, or Tasmanian Blue Gum. I'm sure all of you know this, like the sickle-shaped leaves, these little nuts that they drop with the cap. Smell great, beautiful peeling bark, and a lot of people think they're really beautiful trees. They were introduced to California in the 1800s. There was a bit of a craze where they were planted everywhere because they were thought to be valuable timber or hardwood. But as probably a lot of you know, the story, it's actually not very good wood. It doesn't cure straight. It's really hard to get it to cure and dry correctly and then mill. The boards always twist, the grain twists, and it ended up actually not being very valuable for anything besides like wood pulp and firewood. And even then, people don't really like to burn it because it has a lot of oils and uses a lot of soot. By some measures, it's actually the world's most widely planted hardwood tree. I've seen, I don't know how people get the statistics for that, but I've seen that thrown about. And it's invasive in Europe, South America, as well as here in California. And so here's another little screenshot of our map. And in this color-coded system, eucalyptus is the purple, or if there's anyone there that doesn't see the color like that, it's whatever this color looks like to you. So yeah, as we saw, there's 2,000 plus acres of it in the watershed, pretty widely distributed. That big patch that I highlighted there with the arrows is right along the 101. If you're driving north from Springdale, and yeah, it's that really long stretch of eucalyptus right on 101. And so in other parts of California, it's not really considered to be invasive. One thing that doesn't spread very much, doesn't grow from seed. But here on the Central Coast, it definitely does spread. And it's well documented to spread and to grow from seed. And eucalyptus is known for its high water use. In the past, it's been planted to what's called de-water wetlands. Yeah, it was planted to dry out land and make it useful, or what people thought was useful. And so it displaces wetland riparian vegetation ecosystems. But we also see it planted as windbreaks on ridges, and that's where the maritime chaparral grows. And so the eucalyptus actually can displace the chaparral, and definitely the oak woodland as well.
Hey, Dash.
Yes.
I'm sorry, just to interrupt. We're having a little bit of feedback from your microphone. I'm not sure why it just picked up in the last few minutes.
Yeah, I always. Is that any better?
A little bit. Maybe if you could, I don't know, like step back a little bit, maybe it'll help.
Yeah, how about that?
That sounds a little bit clearer. I think there's still just a little bit of garble, but
Thanks.
I think that might be the internet out there on the west side of Santa Cruz.
Yeah, weird. Sorry, I don't know. I'm not very tech savvy, so I'm not sure how to do it.
Okay, it sounds a little bit better now. Thanks for bearing with the interruption.
All right, maybe I'll just stay back then. Let me know if there's any other issues, okay? Okay. Sorry about that, folks. Well, anyway, where was I? So, yeah, the reason we're worried about invasive species in general and eucalyptus in particular is one of them is the impact on ecology, which is sort of the interaction of all the species that live in an area. And so there's been some great research actually by scientists at the reserve here, and they looked at the plants and animals that live in eucalyptus forests here, eucalyptus groves, versus native coast live oak groves. And what they found was under the eucalyptus, there was less diverse understory. There was less diverse arthropods, so invertebrates living in the eucalyptus. And then in general, there was more generalist or widespread species in the eucalyptus, so then common species basically that lived under or on the eucalyptus. More annuals. You can see in this picture labeled B, that's the woodland. There's ferns, there's coffeeberry, snowberry, lots of perennial plants, evergreen perennials. Whereas under the eucalyptus, we see a lot of annuals, annual grasses, things like thistles that dry up towards the end of summer and die off and spread their seeds for the next year. And so that's important. You know, I think a lot of people care about the species and about the ecology of the area. Something else people are obviously rightly worried about is fire danger. And eucalyptus, there's been lots of anecdotes about eucalyptus flammability, about the danger of eucalyptus, especially starting after the Oakland Hills fires. That was like the early 90s, I think. And more recently, it seems like there's been more scientific evidence that that is true. There's enhanced fire risk from eucalyptus. We know that the tall stature of eucalyptus during windborne fires can be a big issue. So tall, spread flying flammable debris on fire long distances in the wind. They have lots of what are called ladder fuels. So all that beautiful draping bark that eucalyptus actually acts like a ladder for the fire to get up. So this is research from, it was published last year of the fires in Sonoma in 2018. And this shows the percent of the canopy that was damaged by fire for each of these different tree types. And you can see actually the eucalyptus was close to 80% of the canopy damaged versus, you know, the oaks, much less. We have Quercus agrifolia is our dominant oak, Quercus live oak in our areas, slightly less than 50%. Riparian hardwoods, 20%. So it does seem like there is a difference between the native tree species and eucalyptus as far as flammability. Also, generally, eucalyptus is larger, has more biomass, more diverse. Water use is another big concern. I mean, yeah, their fire danger and drought are obviously linked. This year, there's a lot of dire predictions about what's going on, but there's definitely evidence that eucalyptus use a lot of water, and more water than our native trees. There's been a lot of research in South Africa where eucalyptus are widely planted, widely have invaded large areas. And they have big campaigns to actually remove eucalyptus and acacia and pines from some of their watersheds to try and actually increase stream flows, to try and increase water availability. And obviously, yeah, when you have, just in general, if you have like a much bigger tree, more biomass, there's probably more water use. So that's actually one aspect as well. Eucalyptus extremely fast growing, so they put on a lot of biomass really quickly. And deep roots. So there's more anecdotal evidence that they can actually access water really deep. So eucalyptus removal, we've thought a lot about this, and it can be a little bit of a controversial subject because, as I mentioned, you know, there are beautiful trees, people who really like them. And so we've kind of come up with some guidelines or best management practices if you're considering eucalyptus removal. You know, in our case, targeted removal in areas where we can easily restore high-value native habitats. We wouldn't want to like take out eucalyptus and then just have it become some other weed, some other invasive species, and just low-value habitat. That wouldn't make sense. But if we can restore it to something like chaparral that has all these amazing rare species, then that would be a great thing. We also want the eucalyptus removal to align with other management goals for our properties. In this photo, you can see our outdoor classroom. This is near Hall District Elementary in Las Lomas, and the students from Hall District come out once a month. Well, they did before COVID. They come out once a month and have these beautiful lessons underneath this coast live oak tree. But you can see in the background there, eucalyptus. And actually, we had to remove several of the eucalyptus because they were a danger. They were sort of deadfall branches. And so they were threatening the outdoor classroom area. And in this case, it would probably make sense for us to remove the eucalyptus, not only because of the danger to the kids, but also because of our larger goals about teaching about science and outdoor education for at the outdoor classroom. And then obviously we don't want to impact sensitive species. On the Central Coast, monarchs, so very few this year, obviously, come back to their groves. Monarchs do use eucalyptus in certain places. And seabirds, herons, egrets will also nest in eucalyptus in certain areas. And so definitely wouldn't want to remove eucalyptus trees that were utilized by species like that. And then other considerations that people might have, fire danger, as I mentioned. This can be a big reason for someone to want to remove eucalyptus. They have big growth near their house, it's on a steep slope. Views, this goes, this is a reason people want to remove eucalyptus or don't want to. It works both ways, right? Some people like the privacy, some people use access to properties, access to power lines or infrastructure. All could be reasons to remove eucalyptus or not to. And then, some issues. It's expensive. These are really tall trees, really heavy hardwood, can be expensive. Hire professionals to remove the trees. There's a short work window generally between the bird nesting season and amphibian, and when amphibians are out and moving. And so there's not a big work window as far as this type of project is concerned. And then what to do with all that eucalyptus wood. The reserve has dealt with this where, you can't even give it away hardly, eucalyptus wood. But it's very worth doing. This photo is from the reserve, from an area where eucalyptus were removed, I believe, in the 80s. And now it's this amazing, gorgeous oak woodland, lots of diversity, lots of species, lots of great views of the slough. So I think it can be really worth doing in the right situation. And then bringing it back to the title of my talk and to sort of individuals, watershed thinking. I really like this diagram because it shows how everything is connected. There's something downstream of your property wherever you live. And I also like this diagram because it shows sort of flows going in both directions, right? There's groundwater, there's surface water, there's rain flow. And so, even if you live in a small little house or apartment or whatever, you have impact on your watershed. You're connected to everything else that's in your watershed with you. Things like fertilizers, chemicals, they don't stay put. I showed that photo of the Sandhill farm and all of the sediment plume coming off of that. That probably included lots of fertilizers, lots of agricultural chemicals that were bound up with that soil that was going directly into the ecological reserve. And that's a more glaring example, but it's true for the lawn too, for your yard. These things don't stay put. And so thinking about what you do, what you use in your own space is important. And then likewise, many invasive plants, many of these things that we spend all this time dealing with removing from our properties are wind and bird dispersed. So, you know, there might be one person in the watershed who really likes the way that ciabatta grass looks in their yard, but those millions of seeds that it produces every year aren't staying on their yard. They're floating off other people's yards into wildlands, protected areas, and so having impacts to their watershed and to their local region. And you know, like people say, oh, it's a drop in the bucket, but enough drops will fill a bucket, right? It's kind of trite, but it's true. It really does matter. What you do on your property matters for the big picture. You look at what this small organization, the foundation, has been able to do in our almost 40 years. And it's amazing. You know, determination, a little bit of luck, you can have big impacts. And so another really key thing that I think that we're thinking about and we're trying to do, especially in the time of climate change and erratic rainfall, is kind of is what we're expecting moving forward, to try and capture runoff and infiltrate it into the soil. This could just be a rain barrel coming out off your roof. You know, a 1,000 square foot roof, a small roof, and 1 inch of rain is over 600 gallons of water. In the photo here, this is just a little agricultural, it was previously like a water station for cattle, stock pond, that we rehabilitated for native amphibians. And so not only does it provide habitat, but it actually captures water moving down the slope, stores it longer term, and sort of slowly releases it into the soil, into the groundwater. You know, trees are great at capturing rainfall. Planting a big oak tree on your property, that's going to have huge impacts actually for the amount of runoff that comes off of your property. Yeah, we're doing the same thing on the sandhill farm. Planting oak trees and native vegetation, the idea being it captures the rain, puts it on the property, gets it into the groundwater, and has positive impacts on the soil. And so if you're into gardening, if you do have a garden, the thing to do is to take the water, slow it down, spread it out, and sink it into the soil. There's great resources online about rain gardens. It's one of the terms. And basically, yeah, the idea is to take that water and capture it, use it as a resource on the property. And then Ariel's going to present more about this later in the summer, but a great way to avoid the impacts of invasive species. You know, not all non-native species are invasive, but it can be hard to know which non-natives will become invasive as the climate changes or as they evolve. And the easiest way to avoid potential impacts and to improve the local environment is to go native to plants. What you put in your yard or even in a container on your balcony or whatever you have. A great tool, there's a website called Calflora, and they have a little a thing called What Grows Here, and it just shows you sort of what grows in your area. You live in the Elkhorn Slough watershed, and look at our map and kind of get an idea of the general distribution of these habitat types. And learn more about maritime chaparral or about oak woodland. Go to calscape.org. It's another great resource for anyone interested in native gardening. And yeah, we're really lucky in California. We're a biodiversity hotspot. At least 6,500 species of plants native to California. All kinds of amazing, amazing plants. Whatever you like to grow, I bet there's a native version of it. A beautiful native version. So I recommend checking that out. And then, yeah, I just want to reiterate, you and where you live are part of something larger. That's like the watershed approach. Just envisioning you're where you are and what you do as part of something larger, thinking about the impacts that you have. Every action is important. And even very small areas can be critical to the survival of species and have critical impacts to the watershed. So in this case, these photos, this is a Santa Cruz long-toed salamander. It's like one of the most endangered vertebrate species in North America. Restricted to just a few areas of North Monterey County and southern Santa Cruz County. And these amphibian ponds that I mentioned are actually, we're trying to help this species by creating more breeding habitat for them. And then this beautiful little flower, this is the Santa Cruz tar plant. There's only, there's about 17 occurrences of this known globally, all in our area. Once again, North Monterey County and Santa Cruz County. And so it's really restricted to just a few small areas. And so you never know, like maybe on your property or some area you visit, there's a species that only lives right there. And so the actions that you take have really big impacts. So that was it for me, I think. Hopefully you can hear that. Hopefully there wasn't too much feedback. I'm sorry about the technical difficulties. Yeah, I'm available if you want to send me an email about something. And I really like this photo, not only because I like to climb trees, but because it's a tree that someone planted about 30 years ago. Started as a little small nothing, and then look at the size of that and the amount of runoff that it's capturing and the amount of habitat it's providing. One little small action a long time ago had big impacts. So, thank you. Oh, and Ariel, I just wanted to maybe do one thing, if that's okay.
Go for it.
I was going to just show everyone, if they haven't checked out the interactive life form map. Here it is. It's pretty cool. You can kind of zoom in, right, and see has the labels for the different types of life forms. And you can even like mess around with the transparency. So you can make it more opaque, or you can see the aerial underneath. And kind of zoom around the watershed. It's really fun. Yeah, I recommend checking it out. It's a cool tool. So that's it for me.
Well, digital applause to both Kass and Dash. What an excellent presentation. As we can see, there's a tremendous amount of intellectual firepower behind stewardship. It isn't just pulling weeds and cutting down eucalyptus trees, although that is maybe the fun part. But I wanted to just jump in real quick. I'll be moderating the Q&A. My name's Taylor Honrath. I'm the Director of Development at the Elkhorn Slough Foundation. And I wanted to thank our members who are here tonight. I see a lot of familiar names, and not faces, but soon. Our members power all of the work that we heard about tonight and so much more. All of this work doesn't happen without the investment of our community. We appreciate you. We thank you for your continued support. I also wanted to thank Laura Solorio, one of our ESF board members, who's here with us this evening. And if you're not yet a member, but you want to be, and I'm sure you do, I will put the link in the chat right now. And all right, without further ado, we will jump into the questions. The first question that I saw had to do with eucalyptus, and I think it was when Dash, your mic was cutting in and out a little bit, but it's from Della Bossart, and Della just wanted to ask if you could maybe do a quick rundown again of why eucalyptus is dangerous or problematic for our local ecology.
Yeah, I mean, I think so. There's a few main reasons. One being it changes the suite of species that are in an area, and it sort of biases towards the more common species, right? So if we're trying to protect rare species, oftentimes the eucalyptus isn't the place for that. We also have less diversity generally. And yeah, it has impacts to what species are going to be in the area. Eucalyptus does still provide habitat, but generally it's not congruent with our larger goals. If we're trying to protect the rare species, the eucalyptus isn't good for that. Then there's the water use. There's a lot of evidence that it uses more water, and then there's also pretty good evidence that it is more flammable, more of a fire danger on the landscape as well. I would say those are the main reasons.
Excellent, thank you. We have 2 questions from Olivia Mandilk, a member of the foundation. Thank you, Olivia. First question, why isn't Monterey County included in the fine scale vegetation and landscape mapping projects? That one's for you, Kass, I think.
Sure. It's because nobody from Monterey has asked us. So these projects grow organically. And what happened is that Marin County heard about Sonoma County, and then Marin County raised funds to do the project, and then San Mateo heard about it. And the same thing with Contra Costa and not Contra Costa, excuse me, Santa Clara and Santa Cruz. And it's not the counties that actually do this. It's usually a consortium of organizations. So with Santa Clara and Santa Cruz, it's the Santa Cruz Mountain Stewardship Network and all of their members. They all got together, and then we brought in even more members like NOAA and USGS and to go ahead and see if we could get funding for the projects. So I'd love to do Monterey, we all would, but we kind of wait until somebody asks, and then we go and help raise it. That's mostly what I do, is raise the money. but I get to take a time out to map like I did for Elkhorn, which was a real treat.
Yeah, and I'll add that our little watershed, which includes parts of San Benito County as well. By the way, I should have meant to mention that in the beginning. Which is interesting. Our political boundaries don't really mesh always well with the biogeographical boundaries. So yeah, we actually get water from San Benito County as well. But Monterey County, as some of you probably heard, is I think bigger than 2 states or 3 states or something. It's huge. It's over 400,000 acres. So almost 10 times the size of the Elkhorn Slough watershed. And thus, it probably be like 10 times the cost. And we definitely didn't have fun with that. But I hope, yeah, I agree with Kass. I think it's super valuable, and hopefully there'll be some groups coming together to do it.
If folks in Monterey are interested, I would really encourage you to look into the CAL FIRE grants for fire prevention. And they're open right now. They closed May 19th, so maybe something you want to wait until next year. But CAL FIRE has become a huge funder of our projects that gets us to make the fuels maps. We have to do a life form map. So that creates a life form map for everybody. And that is, with the amount of times that Monterey burns up, CAL FIRE is a real good starting place to create an anchor client to build a more robust program like we've done in the other counties.
Thank you both. Olivia's second question is, please clarify the areas that are included in the upland area of the Elkhorn Slough.
I'm trying to think if I've got a map that shows you what is upland and not. The upland areas are anything that is not a tidal wetland. So anything that is mapped where the species that occur in tidal wetlands occur, that is tidal wetland. The uplands are everything above that.
Excellent, thank you. We've got a question from Facebook that Ariel patched through to me. I live north of the Elkhorn Slough, and there's a riparian corridor and small stream on my property. On the GIS map, I can see the riparian section, but not the stream. Are streams indicated on the map? If so, what would we need to do to see it?
That's a good question. Streams aren't, because they're usually under canopies of trees. So, but you're in luck, because the USGS has a great coverage of streams, which can be made better, which we've done in a couple of counties. But there are map coverages of stream locations. In Sonoma and Marin counties, we've actually mapped the location of the streams using the LiDAR data, and it's even more detailed than what you'll find at USGS now for Monterey. I mean, these coverages become USGS coverages, but the reason you don't see it on the vegetation map is because the vegetation is covering the stream, and we're mapping from imagery from above, so we can only map what we see from above, and we can't just pick out the stream. If there's no vegetation over the stream, we can map the stream.
Yeah, that's interesting. That might be that little creek that comes in from the north side of Watsonville Creek, I think it's really called. But that is where the Pajaro River jumped into the slough during the 1994 floods. As I mentioned, you know, how the watershed scale can be defined different ways. I think this is what the commenter was talking about.
This is a good segue, actually, since we're talking about the headwaters of the slough. Laura asked, are the headwaters of the slough in San Benito County? Is that correct, or are the headwaters elsewhere?
No, that's correct. Yeah, the Carneros Creek is the main freshwater source for the Elkhorn Slough. Obviously, there's other little small drainages that drain down, but the Carneros Creek is the main, the main freshwater source, and the headwaters are up in San Benito County, across the other side of the 101.
Thank you. From Lisa Hall, do you know if the oils from eucalyptus degrade the water quality in the slough?
That's an interesting question. Yeah, and the oils in eucalyptus are definitely an issue. Definitely in the soil, it changes the soil chemistry, and that's part of why we think that there's a different assemblage of plants growing in the understory of eucalyptus than under the oaks. But water quality, I'm not so sure. We have a resident water quality expert at the reserve, and so I'll have to punt on that and ask him. But maybe you could leave your contact info and we can get back to you. But that's an interesting question.
Yeah, I thought so too. All right, from Kari Olson, our fearless Kari Olson at Elkhorn Slough. Regarding mapping, how is this vegetation mapping different, maybe better than the CDFW, CWHR, ArcGIS veg mapping?
Much higher resolution, much more fine scaled, so that the existing, I forget what the common name is for those maps, but I actually have a great slide somewhere that I can post if you guys want, which shows the difference in between the existing maps that CAL FIRE produced and the maps we're making, and it's just much more detail, much higher level of detail, both in the types of species that are mapped, the number of species that are mapped, but also in the just geographic. Our minimum mapping unit is an acre, and in the riparian areas, it's actually a quarter of an acre. So it's just a much more detailed map, much more current. There's all kinds of things that make it better.
Yeah, and I'll add on that, you know, as part of this map, and because of the focus on eucalyptus, we made eucalyptus a class, and then also chaparral a class, which was slightly different than the original sort of this original classification. We wanted to pull those two out because they were important for the purposes of the watershed restoration program and our goal of understanding eucalyptus and sensitive habitats.
On that note, Patricia Grogan asked, I noticed that some removed eucalyptus trees had been burned as well. Why was that?
Oh, yeah, great. That's great observation there. That was actually an experiment to try and create biochar. Biochar is kind of a fancy name for charcoal, but the idea is you burn the eucalyptus wood in the absence of oxygen to create this biochar, or like basically carbon-rich charcoal, and therefore you're capturing the carbon, and you can use it as a soil amendment, or maybe as in the nursery for different things, as a growing medium. But the idea is that carbon becomes really stable, and it's a way to sequester it. And also, yeah, the biochar does have uses. There's some pretty good evidence that it improves soil health and soil water holding capacity in agricultural fields. So there's been some experiments on the reserve in the habitat restoration setting, seeing if the biochar actually helps the survival of the plants and increases soil carbon.
Taylor, if I can share my screen, I can show a side-by-side of the CalVeg maps and the fine scale maps.
That would be great.
That one. So here we go. So can you see
Thank
that? Whoop, not yet, share. There you go. So you can see on the left-hand side is CalVeg, and on the right-hand side, this is Sonoma County, is the fine scale map. You can see the difference in the detail, and there are way more classes, and it's just it's a fine scale map versus a coarse map.
It's like 1950s camouflage versus 21st century camouflage.
Yeah.
All right, that concludes our Q&A period. Thank you all for the excellent questions. I think that really informed the discussion. I'm going to hand the mic back to Ariel from Esner, and thank you all for joining us again tonight.
Absolutely, I reiterate that. This was fantastic. I love looking into these maps. I'm still a little shell-shocked by that last slide, how different those two are, and the incredible detail that it's getting to. So kudos for your work, Kass, with mapping and getting us the tools to be able to do this, and to you, Dash, for your work actually getting on the ground to use the map as a tool. Thank you, everybody, for joining us tonight. Our next installment of Evenings at the Estuaries is July 29th. And we will be featuring several experts in a panel talk on Wildlife Gardening 101. So if you've been curious about establishing a wildlife garden in your backyard or on your patch of property, or if you are experienced and looking to dive a little bit deeper, this will have a talk with a little bit of everything. So tune in then. You can keep track of events that we're doing on our Facebook page or on our website, elkhornslough.org. And please have a safe night. Have a good day. Enjoy the sun, and we'll see you next time.